Okay, let's start with an easy problem, LeetCode problem. So today we'll solve from the start. So the first one is to sum. So here we have given an array of integers, and then we have to find an integer target where these two numbers from this array sums up to that target. So so it says you have exactly one solution, so there are not two numbers which sums up to the given target, so it is easy for us. And then this is some example. So here we have to return 0 and 1 as the target. It's up to 9. Okay, example 2, 3 to 4, we have to sum up to 6, and we have to sum 2 and 4, which has the indices 1 and 2. Okay, and here the target is 6, and we have 0 and 1. We have to pass 0 and 1 indices, so only one valid answer exists. And I think they say that we have to come up with a algorithm which is less than or n squared quadratic complexity. We should try below that. So basically the easiest solution is like loop through these twice, 2 for loops, and then find the sum. So that will be a kind of brute force. So let's do it first and then try to understand how it works. So I'm using Golang language, so I will go here, range. So what I'm going to do is I'm going to range through numbers, and then I have to go through the range again. This time I will use a indexes. I will start from my plus 1. Then j is less than nums j plus. So actually I will go here also as nums because I want to loop through less than one element of the nums, because I'm adding plus 1 on the second loop. I have to make sure that it does not go beyond the array. Also I have to check the nums greater than or equal 0. If so, I can simply return an empty array. Since I'm using len nums multiple times, I think I can return into a variable. So it is easy and clear. Okay, so here it comes in. Okay, then I should check whether the numbers I have at hand now sums up to the given target. If so, I can simply return an integer array which has these 2 indices. If not, I can simply return an empty array. I don't think this is the case because the question guarantees we have exactly one solution for this problem. Okay, let's try it out. Wrong answer. This nums I equals nums j. Let's target return. Oh, here it is wrong. This should be less than or equal 0. Okay, it works. Let's submit. Accepted. But you see that it is 28 milliseconds to 28, and memory is also is using somewhat memory, and then it is faster than 30%. So if you consider this as a score, it is like I'm getting 30% only. So why not we try another way? So this time what I'm going to do is I'm going to take the complement of this number. So for example, I'm going to loop through this array once, and then I'm going to have the complements of each number with the target stored there, and then if I see the complement somewhere, I can return the indexes. So for example, when I see 2, I should check whether I have a 7 in the rest of the array. So here I see 2, 7, so I can return 2 and 7. Yeah. So what I'm going to do is I will do the same check, even it is not necessary. It's a good practice to have edge cases and test these things. So here what I'm going to do is I'm going to have an array which says complements, and it's a map which I'm going to have integers. So this is basically will store the complements I'm going to see. So I'm going to look through the array again. It's range nums. So what I'm going to do is when I see D, I check if I check let's say what I have stored is like say A for the moment, complements. I'm going to try whether this has the complement of this number, so I'm going to check for target minus D. If it is okay, and I should check whether D, if it is okay. If it is okay, that means I have to find the complement for this number. So I should return an integer array which has I as one integer. Let's insert the value of A as one integer and I as the other. Otherwise, I return an empty array. Also, if it is not there, what I should do is I should insert this. Actually, I don't need an else block here because I'm returning from that anyway. So complements target minus D. I'll have the I as the index. So yeah, I think you got my approach. I'm maintaining a complements array where I'm going to have a map. It says wrong. Why? Let's go through this first. So this one is not going to execute at all, and here I'm having an empty map, and then at first I'm going to have number 2. So complements do not have a 9 minus 2 7 there, so it comes here. Then I'm inserting 9 minus 7. I should make it like this. That is where I got wrong. Yes, correct. So what happens is in the map, your key is the complement of the number you are checking, and if it is not there, you are adding that number to the map. so in case you see the complement, you can find it. Okay, let's submit it and try it out also. Oh, cool, it works 4 milliseconds and then it's 97% faster, and it uses a somewhat more memory. Why is that? Maybe it is because of the map. Let's try to improve further. So another thing that came to my mind is like, what I can do is I can I can something like this. Let me explain. What I can do is I can sort these numbers first, and then I can have 2 pointers. So for example, this one is already sorted, so I will have 2 pointers from here and here, and then loop through this array once. So when I see 2 and 15, I see the sum is 17, so sum is, but my target is 9, so 17 is greater than 9. So what I will do is I will decrement my pointer at the higher end, and so such way I will try to find out the two numbers which are getting given with the target sum. But to do this, I have to sort the arrays, but when I sort that out, I have to I will lose the indices. So what I need to do is I'm going to have a copy of the array first, and then only I can sort it. So I will say I will get an array called copy nums. I will make an integer array which has the size of n. Then what I will do is I will copy my source will be nums, then my destination will be copy nums, then I will sort ins copy nums, then what I will do is I will define 2 variables as high and low, where high is n-1, because I'm going to have the farthest entry as the high and low as 0. Then what I'm going to do is for low is less than high, I'm going to go through this array, and then I'm checking with the copy nums, copy nums low plus copy nums high equals target. I'm checking out that. If so, oh, I need some indices. I have to store the answers also, so tell them I will call them A, B, which I will assign them to 0 first. So if these two are equal, I will assign A as what I need now is the values of the numbers. So B equals copy nums high. I think I need this sum as, let's say, current sum. I am going to use it multiple times, so I'm going to have it into a variable. Else if current sum less than target, so So the number is less than target, current sum means smaller, so I will increment my low end, otherwise I will decrement my low end. So when I get out of this for loop, I have two integers which are a and b. So now I have to find the original indices of those two numbers a and b. So I will have an array called answer, which is a integer array. Yeah, I will make this a slice so it's easier for me. Okay, then for I range nums if d equals a or d equals b, I should have my answer as append answer I. This is the indices I'm going to have going to okay, so what I did was I just first sorted my numbers, and then I'm having two indices to the start of the array and the end of the array, and then I'm coming towards each other, looking whether those numbers are making the target sum. If it is target sum, I can have a break here because I don't need to check, because the question says it has exactly one solution. So once I found it, I don't need to go through the loop anymore. And then what I'm doing is, once I found those numbers, I'm going to get the original indexes of those numbers in this array and return the answer as it is. Let's see what happens here. Compile it. No new variable 39. Oh, this one. Cool. It does not give me the answer. Why? If d equals a or d equals b, answer I append. Oh, I think I got this wrong. I should not use a. Is here. I should do is create an empty array, and then 0, 1, 2, 3. I can print here too. Let's try it again. Oh, this is allowed. Append answers I break. Output is 0. Yeah, because I cannot break it here. I have to wait for the B also. What is giving me 0, 1, 2, 3? Crazy. D equals A, D equals B, 0, 1, 2, 3, 0, 1, 2, 3. If D equals A, or D equals B, answer should be these two only, but if let's print this out and check how it works. A, B. Let's see how is that. 0 0. So it means here it is not going to give me the sum. Low is less than high. Less than high. If current sum equals target, then this one break. Okay, then this is not happening. I see this one. Okay, source destination. I think I got those two wrong. Yeah, it's correct. Okay, then yes, it seems to be working. Let's submit and try it out also. Oh, cool. It uses less memory, same milliseconds, and yeah, I think this one is better. Yeah, that's it. Thank you for watching.